Now we're going to learn about how to find the volume of a solid revolution. So for this example, we have our two functions. The top one is f, that's this graphs this way, and g of x is on the bottom down here, and the region between is what we want to revolve around this x-axis. Here is the y-axis. Now since we're going to revolve it, there's going to be a 3D aspect to this, so let's just get used to that. Here we're turning the object, the region. We can see what's happening here. And now we're going to revolve that region about the x-axis. So to find this volume of the solid part, we just cut it up and add up the slices, the volumes of the slices. So let's take a look at those slices. First we start off with a Riemann rectangle, and you can see that these rectangles cover the area of the region that's being rotated. And we've already done that, found the area between two curves. But now we're going to revolve that. It's one way to look at it. And so these slices are going to just be, in this case, rings. We've already seen examples of discs. And as we move them along, we are creating the solid. And of course, these are rings of width or height across here of 0.5. We could have them bigger to be less accurate, and we could move those. You know, we'd have a less finer approximation of the volume, or we could get real fine with it by having them be, say, 1/1000ths, and they would just be very tiny, very thin, and as you added those up, you'd get a very good approximation to the volume of that solid. So that's the idea. And of course, in the limit, when the delta x's go down to 0, you're going to get the exact volume of that. So one more time, here is the process. We have our region. We're going to revolve it around the x-axis. So we just go ahead and do that. Then we take cuts. Here's our first cut, the next one, so forth. and we just add all these up. Now these rings are nothing more than cylinders with holes in them, so we could easily find the volume of each one of those rings. Form a Riemann sum, take the limit as the width or height of these rings going this way, goes down to 0 in the limit, and we'll have the volume.